equal to -5 over this. X squared plus 3x plus 2. And let's make sure all that's gotten down correctly, looks like it is. Now, you guys, in the 4 o'clock session today, we'll get a benefit here. You've already seen something like this worked out. What's the clever way to approach this problem? Well, first, I got fractions. And I know how fractions are, just crazy. Please tell me, before I jump into it, if you were across the street at that middle school, and my goodness, I think they do this across the street, they may do this in elementary school, they probably do. But if you had this, which is a fraction, and somehow you had put this with it, another fraction. What does one do? What does one do if you have 2 fractions and you want to put them together? Because maybe over here, I have 2 fractions here that I got to put together. So what are you going to do back here in elementary or middle school, which I'm going to do here also, are you going to come up with a common denominator? And put them over a common denominator, which in this case is easily done for the middle school problem. What is it, 4? And since it does not have the 4, you can multiply it by what, 2? That's one way to do it. Now, does everything have 4 for my denominator? And on top there, I have merely 3 plus what? The 3 plus 2? I did that real quickly. Is the elementary school problem 5 over 4? I'm going to do the same thing here. Same process. And what's that process? I need to, if I could, come up with a common denominator. Since I'm talking about a common denominator, I see 3 fractions here. So let's just take care of all 3. And as you take a look at all 3, I do recognize, and I think most of my students, if not all my students, recognize, Professor, I think that last denominator will factor. It's x squared plus 3x plus 2, I think it's going to factor into, and I can make it look like that. Which really helps me because when I look back on my left-hand side, I see things matching out. Now, please tell me, what do you think I'll look for a common denominator like I used a 4 here on this one? What do you think I'll be using for all 3 fractions? What would I like to have underneath them as a common denominator? Give me an idea. I'm going to call this step 1. I see this one has this in the blue. So if I want to use the blue one for my common denominator, I like to see that blue underneath each one of my fractions. This one's missing, I got to put it in, the x plus 1. And when I say put it in, numerator and denominator. This one's missing the x plus 2. And the last one, of course, on the right-hand side has it already. Now, everything's over the same denominator. Now, her question was, she said, Professor, I follow you there. I know how to put everything over a common denominator. She said, but all of a sudden, you just jumped up and started working with, to finish this up, you started working with the numerators. The top part, right? Guys, this is what I'm going to do now when I thought about it. She said, Professor, what can I do? You could do this. And some textbooks will show this. Since you have to count everything over the same denominator, guys, watch what happens here. You can now say, Professor, suppose you went through and multiplied every fraction by that common denominator. I'm going to put it on the side here. X plus 2, x plus 1. Multiply every fraction by that. Watch what happens. That was her concern when she asked me. Guys, what's going to happen if I multiply the first part here, this first term, where it looks right now with the blue, by this green? Will the x plus 2's cancel out? Will the x plus 1's cancel out? What's that going to leave? It's going to leave me merely what? 3x times x plus 1. When I do the same thing on my second fraction, I'm still multiplying by the green. The x plus 1's will cancel. The x plus 2's will cancel, leaving me this, the numerator. And of course, the other side is super nice because x plus 2 cancels out, x plus 1 cancels out, and leaves me that. Now my fractions are gone. I've cleared the fractions out. And I think that was my concern, that was the question. Why did you just deal with the numerators? That's what it comes down to. Now, can I finish this up now? Let's do distributive property. This is 3x squared plus 3x. We'll do this slow tonight here. Down here, minus 5x minus 10 equals -5. Little distributive property. Combine like terms, we end up with 3x squared, definitely. I see these can be put together. Like terms, combine -2x. What would you suggest now I do before I finish this up? The next step. What should I do? Anyway. What would you suggest I do if this thing's gonna work? Yeah, move this over, because you need one side to be 0. And guys, if I move that -5 over by adding 5 to each side, and I will put it right here just to show you what I'm doing. I'm doing this, adding 5. These will drop out, which I want, gives me a 0. The other side though, -10 plus 5, what's it, -5? And there you got 0. Please tell me, would you love to open up your quiz or exam, and Professor Ramsey had asked you to solve, and I had given this to you looking like this to begin with, and not this? Wouldn't that be nice? Solve this. No, it's going to be in this form where you get to simplify it first to get to here. But darn, if I gave you this down here to solve by quadratic formulas, quadratic, or by factoring, that'd be much easier. But that's where we are. Guys, we'll try to factor this one. You guys who like quadratic formula, go for it. It will also work. Don't try to factor. Just try 3x and x, factoring skills. Now, on the end, I don't have much choice. I got -5 on the end. So it's -5 times 1. Or a +5 times a -1. But where do they go to make this thing work? So don't give me a choice. -5 here, +1 here. Or +5 here, 5 here, and -1 here. What should I do? Give me a choice.
-5.
-5 first, okay. And then?
+1.
Thank you. Now to make sure you put those in the right positions here, I always do this. I check the product of the last, this product, 3x. And I check out the product of the inside, -5x. And guys, a -5x and a 3x, well, that combined to a -2x, which was in the middle to begin with. So that says I've had positioned these correctly. I just do that little check there. So it's been factored correctly. Now, when I split this up, thank goodness that zero's over there. They call this the zero product property. You're allowed to write each one of these equal to 0. Easily done. I'll do this one quickly, guys. X is 5/3, that's no problem. And x is equal to a -1, or the other possibility. Is that true? And you guys who like quadratic formula, go for it, you'll get the same answers. That -b plus minus square root business. Now, you say, Professor, right now you're telling me 5/3, after all that work, and -1 came out. I am. Now, more than likely, when I create your exam or quiz, I usually ask students before they do all this business, please point out, just to make sure, what can x not be when you first solve the problem? Give it some values for x that if I get them, I cannot use them for a reason. What x's can I not use for values? -2 and a -1. Why can I not let x be a -2? I'll get a 0 denominator. You can never divide by 0. Why can I, if I got it, -1, in fact, I think I got -1, and I can't use it. If x is -1, that would force this denominator to be a 0. Again, you can't use it. Therefore, I gotta remember to go back in and cross this one out. The only answer is 5/3. I'm not gonna ask you to check 5/3, that would take forever. Let's go back and plug in 5/3. But at least -1 is that number that you can't use. Now, does that help? I hope. I thought about someone on the freeway about that issue. Does that help? So when you see one of these fancy things with fractions, the common denominator. Be careful. This one's done. Part B. I wrote myself a note here. Oh, I sure did. One more that a student asked me about. Professor, how would you solve this? How on earth would you solve that? And I want you, I think most of my students know, I think we're expecting 3 answers. We're expecting 3 answers. And if someone tell me an approach to do on this, think of this, there's no fractions. There's no common denominator. Does someone see a clever way to set this up and try to find those 3 answers?
Split it down the middle.
Oh, I heard the key word. Oh, wait. I heard grouping, right? Now, when you say grouping, would a group make what, the first 2?
X plus 5x.
Guys, hang on now. I'll group those 2 like that. Let me use a different color. And then you want me to group the last 2 like that. He wants me to split up, which sometimes is beneficial. Now, what can I do in that first grouping there, guys? X cubed plus 5x squared. Is there something I can do there? Do those 2 terms have a common factor? Yes. Take out x squared. Take out a common factor of x squared in the first 2 terms, and you have that left over. Now, he's asked me to group the last 2. What on earth can I do with negative x minus 5? I'm desperate.
-1.
Take out a negative 1. Now, if I take out a negative 1, I'm careful, I mean really careful, on the end. Take out negative 1, that means go back and divide each one of these by -1. This is what really turned into x plus 5. Now, who on earth would think of this? Grouping. Unless Professor Ramsey would put on the side, use grouping. Would that be nice if I did that for you? So you wouldn't sit there and think on your own, just use grouping. Like you get them quickly. Guys, am I finished? I'm not finished yet. Now what? Is there another common factor now? Is there something common now, even at this point? Is there an x plus 5 in both those terms? So let's take it out as a common factor. Now be very careful. I'll take it out of the first term, we're going to have x squared left over. That's no problem. Minus what left over on the end? If I pull out x plus 5. 1. Now what?
Factor x squared.
Then you want to factor again. And in fact, that what, x squared minus 1 was classified as a difference of squares. You say, wait, Professor, factoring's not done yet. X squared minus 1 can be quickly written as, by difference of squares, x plus 1, x minus 1. It's right here, called a difference of squares. Now, I'm able at this point to split these up finally and set each one of these factors equal to 0. Guys, it's easy from here to solve the first one, no problem. It's negative 5. Solve this one, no problem. Negative 1. Here, 1. And sure enough, I got 3 zeros, which we thought we should get, and they are negative 5, negative 1, 1. Now tell me, why might I not be too concerned about, should one of those be rejected? On my first problem, I had to reject one. What does this one not have that the other one did have, where we had to be more cautious? Why was a check definitely needed on this one? And I'm not going to check this one. I should check all of them. I'm not going to check it. I don't want to accept those answers. Why do you think maybe I don't have to worry too much about unless I made a mistake in my math? I check there. Does this second problem have any fractions? No. The first one had fractions. That's where you got to slow down and say, hold on. I may end up with a 0 denominator on one of those fractions. I can't let that happen. Thank goodness this one has no fractions, so I think we're okay here. We're done. Now, part two. Something else the student was asking about, after class. That's why I like to stay after class for just a few minutes, see what students have to ask about. It was, sure enough, here goes, this. Solve. And all of a sudden, it's an inequality, not an equation. And this one looks like this. X cubed less than 9x. Now this may be a little new. I think I just had a chance to start on Monday. Inequality. Any suggestions? Not equation. Inequality. Anything that you might say, Professor, I'm desperate. I got you something to get a few little points on this. Partial credit. What would you do? Give me an idea. Yes, go for it.
Start by moving the 9 over to the left side. So
The 9x? Here we go, hang on now. X cubed, when we move that over, which now it's going to look like this, less than 0. Why is that 0, less than 0, so important on inequalities? Less than 0 implies I'm looking for an expression to be what? Negative. And did I introduce sign analysis last time? We talked something about sign analysis. So this comes down to when students told me to move that 9x over, less than 0 says I'm looking for a negative to come out in this sign analysis when I get started. But at the same time, since I had the 9x moved over, I can do some factoring. Is there a common factor of x? If I take that out, do I have this? And if you take a closer look, there's more factoring. How about the x squared subtract 9? That's what, a difference of squares? Like I think we had an x squared minus 1 back over here. This was x squared minus 9. It will factor further by difference of squares, which is one of the easiest things to factor. It's x minus 3, x plus 3, less than 0. You get partial credit for showing me that. Now, this is less than 0, it's not equal to 0. It's not an equation. So this is where I would suggest this, which you're going to really like when you reach math 7. They call it sign analysis. And what we're going to do is, we're going to make it look very, very, very nice here. We're going to draw a number line and place on that number line I'm going to call them, let's call them zeros or answers. What would the answers be if this were an equation? Suppose I split those up. What 3 answers would I have to look at? I think if I split it up, I get what? 0, 3, and negative 3. I'm going to place those right here on the number line like this. Now, are they to be included? Well, it depends on my inequality symbol. Is there an equals mark here that says inequality? No, so they should be open. All 3. As a professor, I sort of remember Monday what you did briefly, introduction to sign analysis. Easily done, guys. Now you're going to check and see which one of these intervals is going to satisfy what we want. You get to choose a number. I don't know what number you choose. Out to the left of -3, but you got to show me what you're using, and we'll try -5. It's up to you. In between, we'll try -1. Here, we'll try 2. And out to the right of 3, we'll try 10. Sign analysis, sign. I'm just concerned about the signs. What I'm going to do, I'm going to be patient, go back, and replace those x's with my chosen numbers in the green. Just a sign, that's all I'm concerned about. Here, if I replace x by -5, of course that's negative. -5 subtract 3 is a -8. Just concerned about the sign. Negative 5 plus 3 is another negative, negative 2. I think they're all negatives. So what is a negative times a negative times a negative going to give me? Negative. Please tell me, is that the implication here? When we say less than 0, are we implying you're negative? So that means you have discovered one interval that works. All these numbers work. It's not like an equation. All these work. Shade in there, that's done. I've seen some of these where the entire number line works. Negative 1, that's my choice. Replace x by negative 1, you got a negative. Negative 1 subtract 3, negative 4. And negative 1 plus 3, I think it's a positive 2. Don't we mess up, guys. Is it negative times a negative times a positive? Which I think gives you what? A positive. Is that what I was looking for? It says, no, you're looking for a less than 0, negative. That did not come out to be negative, so I can't use it, can't shade. That's not part of the answer. 2, trying 2. 2, positive, no problem. 2 subtract 3 gives me a negative. 2 plus 3 gives me another positive. And guys, if I put those in, I put them in quickly, I think it's a negative altogether, which means I have discovered another interval that satisfies what I want. 10, I'm trying 10, replace x by 10, of course, get positive. 10 subtract 3, 7. 10 plus 3, 13. All positive, can't use it. Now, what's my answer? What's my answer to this up here? This is the original problem. So you're going to place on the side here in interval notation what worked. Now, be very careful as you read these number lines. Anyone tell me in interval notation, what's implied here? Everything to the left of negative 3. It goes on forever to the left. So how would that be written in interval notation? Negative infinity first. Up to negative 3, open. And then we'll put a U for union. And there's another piece that worked. Another interval. This little piece here. Now am I going to write this? Parenthesis 0 up to 3 and close it up. There's your answer. I love sign analysis. Sometimes I teach calculus. I love the sign analysis. Big help. Okay? Now what I want to do is make a little connection here for you. I want you on the side here. Watch carefully. I want to move that 9x over and think of it like this. I'm going to write it as a function. Watch the connection here. I move the 9x over. This problem's finished. There's a little connection here. I'm going to move the 9x over, so it's x cubed minus 9x. I'm going to think of that as a function. I'd like to graph it. We're going to do a lot of graphing this way. A lot. I'd like to sketch this crazy x cubed minus 9x and see what it looks like. Is it going to be a parabola? No. Is it going to be a straight line? No. What type of a curve is this thing going to be? Now, let me show you what's going to happen here. Let me go use my different colors here. Let's see if this will work. There's a good color here. Got the green going on, it turns into blue. X cubed minus 9x, guys, here goes. I've got my major numbers to work with already, back here, on that problem. What do you think the graph, if it's negative, on this interval here, what do you think the graph, which we have no idea what it looks like right now, but where do you think it's located? Do you think it's going to be located below or above the x-axis, since this came out to be a negative? Where do you think that piece of the graph? I don't know what the graph looks like myself right now. We're going to finally get the full graph. What do you think it's going to look like if that came out to be a negative in this interval here? Where's my graph located? It's going to be up here, or it's going to be down here?
Below.
Below. What it looks like, we don't know. It's going to be a curve of some sort. So I'm going to make it look something like this. But definitely it's below. And it goes up to negative 3. Now this is better. up to -3 there. Now the next interval, I got a positive, right here. What do you think that means for me to do now? Where should I go? Positive implies I should do what with my graph now? Go above the x-axis. Now how far above there am I gonna go? I don't know, you don't know. It's gotta come back, pick up that. Then so I'm putting little curves to it, not a straight line. The next interval gave me a negative again. That means, oh, it drops down below again. Now how far it drops down, I don't know, you don't know. It's gotta come back up. And what's it do over on the end? I think we've got what, positive on the end? What's that imply that it's going over here on the end? It is above. Mr. Parker, I don't have this graph precisely. Would you, on one of you have back there to work with, would you graph, maybe, well, this, x cubed minus 9x squared, and then describe it for me. See if it takes a shape like this. X cubed minus 9x.
It looks similar.
Okay, similar. The only difference is probably maybe, does this one go up higher or lower? What happens there?
It's symmetric.
Oh, it's almost
Yeah,
symmetric.
it's,
Okay, and you would not know that unless you tested some points in between. Actually plotted a few additional points. But basically, Park, Mr. Applied Math, you're telling me this is,
yeah, it's.
thank you, that's all I want. There's the graph. There's the graph. Now, if that's the graph, please tell me, whew, we got the graph. If I had given you this first, the blue graph, I gave it to you. On the test, I said, this is its graph. And then I asked you to answer this question. X cubed minus 9x, that's its graph, that's its picture right there. That's the picture of x cubed minus 9x, right here. And then the question came out, when is that less than 0? That means now, if you want to answer this by looking at the graph, what part of the graph are you looking at? If I want the part that's less than 0. And I'll shade that part in. The part that's where? Below? Okay, so that means this piece is below on my graph. That satisfies this, it's below 0. Where else is it below? Are those the only two places where it's below? Is that true? On the graph itself. Now, how would you describe that? I hope you'd say, Professor, from negative infinity all the way over to a -3, I guarantee you this graph is falling down forever. Is it going to stay below always? Is it dropping down below? Is it going to ever come back up? No. Is it dropping down forever? So it's going to stay in this interval from negative infinity up to a -3, which we got earlier. And where else is it below? It's caught between what? 0 and 3. Same answer. Without going through the algebra, without going through the factoring that we did, without going through sign analysis. Just look at the graph. Now, I'm not going to do this with my sign analysis, but I think with some questions here. Suppose I turn this around. Please tell me, real quickly, without going through, move the 9x over, factor out the x, Professor, difference of squares, Professor, sign analysis, Professor, and all of a sudden, I say, now, please, fairly quickly, tell me when is this true without going through sign analysis. Well, you got the graph in front of me. And what's that graph going to be here? This is x cubed minus 9x, we said that before, is greater than what? This time it's greater than 0, implying, what am I looking for this time? When is my graph where? Above, positive. When is it above the x-axis? Please tell me, is it above here? We're calculus already. And is it above here? Is that true? And not touch sign analysis. Not touch factoring. So the answer to this right here, without touching anything at all but the graph, says it's true from what? What was this, guys? -3, was it? I think it was -3, wasn't it? -3 up to 0. Union, and also it's above from 3 out forever, 3 through infinity. And there's the answer. That's the benefit of having a graph. I don't think, from the looks I see on some faces, I don't think you guys knew how to read a graph. You just accepted the graph, you didn't know what it meant. You said, oh, it goes up, it comes down, does this, and does that. You didn't know what that meant. That above or below plays a big part of calculus. Was it above, was it below? Yes?
What's that kind of graph called? Squiggly?
Okay, so let's wait till chapter 3 when they introduce us to polynomials.
Oh,
It's going to be a polynomial function. It's not given a specific name, like parabola or straight line or something. No.
okay.
Okay. Guys, would this help? Please tell me. I'm constructing my exam for next Wednesday. I'm working on it already. Would it help if I did one problem where I just gave the graph? And said, please solve something like this, where you don't have to touch factor. You don't have to touch sign analysis. Just look at the graph. Is that true? Now, I gotta be careful myself though. It said, it didn't say greater than or equal to, did it? Now, if it had said greater than or equal to, what would I have to do to change my answer a little bit? Suppose there an equals mark in there. What would you have to do? Help me out. What's the only difference in what I have right now? One will change. If they had thrown also an equals mark here, which they didn't, what's the little one will change? Yes?
You put, brackets.
Yeah,
instead of-
exactly. You put a bracket around -3. Just right on the axis here. And a bracket around 0. And a bracket around 3. That means that those could now be included if you saw less than or equal to. The benefit of a graph. And then my two students over there, who were already gone through some of the higher math, you're gonna see a lot of this. And those professors, when I teach calculus, we don't have time to mess around. That's why I see some of my colleagues, the students in their offices crying now. I actually see some crying. They see, we're walking to a math 7 classroom. And all of a sudden I had one come in during the 4 o'clock session. That was what was happening to him. He said, sir, do you have an ag code for math 2? Not now. Math 7, they just go like that. Okay, so we gotta get you ready for it. Guys, this is nice. This is really, really nice. Part B, before I leave all this meeting to where I should be, I had to do this. Help for you guys doing this. Here we go. Part B. I'd like to solve this one, and with your help. And it looks like this. Seems like I took this one from a calc textbook. They had this, x to the 4th times x subtract 2. Like that. All over. And x squared plus 5. And they want to know when is that. I'm gonna make this one easy. Now, I am not gonna graph this one. You would not believe what the graph of that strange thing is. It goes crazy on you. It's not as well behaved as that last one. We're not gonna graph it at all. I am gonna use sign analysis. I'm just jump right into it. Guys, draw my number line, be ready for it. Place my so-called critical numbers, and I gotta be careful what numbers are being used as critical numbers on this strange problem. And then we'll start the sign analysis. Anyone tell me? And the reason I like this particular problem is you don't have to do anything to it. No factor. It's ready for you. You don't have to clean it up at all. Now, can anyone tell me what you think my critical numbers are? They were these back here. What are they here? I'll take positive 2 for sure. Positive 2, wonderful. Oh, I love that. Hold on a second. Hold on. Who said -5?
Me and I think
I see what you're saying. Now, if you're just saying, no, Professor, I'm taking it back. Why is it not -5? Because if I had not placed that square on it, she would be correct. Is that true, guys? X squared plus five, if I change it to x plus five, yes, she's correct, you can't let x be a negative five, you get a zero denominator. I had an x squared from that calc problem, therefore I don't have to worry about that on this one. So I got the, two a student gave me, and I see one more that you might overlook. There's one more critical number to be placed on that number line. Then I'll start testing, like I did this one. What's my one number you're overlooking?
0.
0. Now you say, Professor, how'd you get those? I would, for a beginning student, I'd say, well, I'm gonna set this one equal to 0. I'm gonna set this factor equal to 0. And yes, I would try this one, sometimes it works. And try to solve and find my critical numbers. I said each one of my factors equal to 0. If I do here, guys, implied is 0. The only number I can think of raised to the fourth power is 0. That's where that came from. This one, of course, the student gave me 2. If you solve for x, you do get 2. I'm going to place this. And this one, you can't solve it. You move the 5 over, you're doing a square root of a negative 5. It's impossible. So I have only 2 critical numbers. Now, question. Should they be open, closed, or what here? 0. Should it be open, closed? Because I had, this one, all 3 were open. Now, I notice I threw an equals mark on this problem. So something might be closed. Any ideas? Anything at all? Should I darken in both those? Could they be included? In other words, can I do this? And show that, in this case, be careful, you are allowed to use those. Am I allowed to use those 2 numbers there? If I go back and replace x by 0 or x by 2, right here, would I run into any difficulty? Would that force the denominator to be a 0 if I should put a 0 in? No. If I should put a 2 in, will I end up with a 0 denominator? No. So those are okay. We're good. They can be included. Now I'm ready to test. See what the answer looks like. Here goes. Again, guys, that test number is up to you. Out here, I'm going to try -3. In between, we'll try 1. And out here, we'll try 6. Now, just look for signs. Let's try -3. What am I going to do? I'm going back here. I'm replacing these x's by -3 and see what sign comes out. Guys, -3 raised to the fourth power. -3 times -3 times -3 out 4 times. It's a positive 81. I'm just concerned about positive. Put a -3 here. -3 subtract 2 is a -5. Just my sign, please. Denominator, -3 squared is 9. 9 plus 5 is 14. Another positive. What is that all together? On top is a negative. Positive times a negative. Over a positive. So would that give me all together what?
Negative.
A negative. Now, look back. Does this imply that's what I was looking for? I'm looking for something greater than 0, which implies what? I'm looking for a positive, so I can't use it. I'm gonna jump down here. It'd be horrible, but nothing works. Try 1. Replace 1, 1 to the 4th, no problem, it's a positive. 1 subtract 2, that's a -1, but I'm just interested in the sign. Denominator, 1 squared plus 5 is going to give me a positive 6. Guys, all together, please tell me, did I put that in correctly? I'm getting scared myself. Is all that put in correctly? If it is that a negative over a positive again? Is that what I'm looking for? No. I'm looking for something greater than 0, positive. Maybe the last one will work. 6. Put a 6 in here. 6 raised to the 4th, big number, but it's positive. 6 subtract 2, that's a positive 4. 6 squared, 36 plus 5, that's going to definitely give me a positive. Do I finally end up with a positive? Which tells me after all that effort, where should I shade to show the answer? Is all this right here. To the right of this. All the way through infinity. The truth? Now, I want a clever student to help me out. Let's get that part out of the way first. That's the only part that worked here. The answer here would be, I'll put a comma here. Guys, it's this in interval notation, so it would help me out. How would you write this in interval notation? You're going from two, closed in, forever. Go for it.
Bracket to infinity.
Love it. Love it. And never put a bracket on infinity. Now, I created this one, or I saw it in the account book. But there's another issue. The big chunk of this problem's done. We did it. But can anyone tell me what else I had better be careful with before I leave it? So, do you see that zero darkened in? If it's darkened in, it says you better include it, even though it's all by itself, it's still part of the answer. It's not open, it's closed in. So I've got to put a union here, and I say, Professor, just one number, zero. I'm gonna write like in set notation. There's your full answer. You gotta pick up that zero. That's part of the answer. If it had been open, no, you'd be finished, not include zero. Guys, I thought about that, and see if I can finish with this. Let's go back to functions. Here it is. Letter C. I gotta watch that time here. We're doing well though. Letter C. Looks like this, the last one. Solve. Show the interval notation. This. X over x plus 2 less than or equal to 1 over x. X over x plus 2 less than or equal to 1 over x. The last example, we'll go back into functions. Any ideas? We are going to use sign analysis. But what might you want to do first before you jump into sign analysis? Yes?
Cross, like.
Oh, I see what you want me to do. I like a little cross multiplication. This times this, and this times this. I will eventually. Maybe something like that, but not right now. Something else has to be done, easily done. Let's see if you recognize it. Then we'll try to clean it up and make it work out for us. Yes?
Move the 1 over x.
I gotta get that one side to be 0. Perfect. Perfect. Move that over, make it minus 1 over x, less than or equal to 0. I guess it's the toughest one I think of the group. Now what? Yes?
X is equal to -2 and 0.
Oh, beautiful. So I cannot use -2, beautiful. I cannot let x be a -2 or a 0. I think everyone in class, the help my student gave me, sees why. Okay, I like that. X cannot be a -2 or a 0. You're welcome. I'm not. Students are clever. I'll live with that. Now, what else is needed? This last difficult problem. What made this one so easy here that we did? And this one not as easily done? What's wrong with this one compared to the last one? Take a good look at the way they present this one that we're in calculus. This problem here, that's the way it's presented to you. And all of a sudden I presented yours like this, which we did this. What's the difference? Yes? You got them together. You got to have just one single fraction, which the calc problem had to begin with. That's what made it easier. I don't have that. I've got to put these two together first, which means I need to come up with a common denominator. And does anyone suggest to me what do you think that common denominator looks like? If I want to put those two fractions together. I've got this and got this. What am I going to use? What's my common denominator to put those two fractions together? That'll help you. this is my common denominator for those two fractions. I want everything over that. On the left-hand side, put those two fractions together, like 1/2 plus 1/4, back in elementary school. If I want that, this one's missing the x. So I put the x in, numerator, denominator. This one's missing the x plus 2. I put it in. Now let's look on top and see what we have. Same thing that I did earlier with fractions. Trying to put the fractions together as a common denominator. Guys, I now have x times x, that's x squared, on top. Then I got subtract, I got all this right here on the end. And I can write that easily as negative x, be careful, subtract 2 is less than or equal to 0. Is that true? Now take a closer look at it. Can someone see something else maybe that would help me to go further before I start testing?
You can factor it.
Thank you. Stop for factor. And guys, I'll factor right quickly for you once you know how to factor by now. X subtract 2, x plus 1. The bottom part stays like it is, denominator. And there, finally, with a little effort, with your help, I finally made this look more like what was presented to me to begin with on this one. They've all been put together. Now I can apply sign analysis. If I apply sign analysis, let's see what's going to happen. Here it goes. Can someone look at the green and tell me what are my critical numbers to be placed on the number line? I always have to place your critical numbers first, then we'll test. What are my critical numbers for green? Anyone? And I see 1, 2, 3, darn, I see 4 critical numbers. Yes, I heard 2. I'll put 2 on here. I'll come back to it. What else? Negative 1? I'll put it here.
-2.
I heard -2, I agree with you, it's down here.
0.
And I heard 0, okay, -2. And don't leave out 0, those are the 4. Those are my 4 critical numbers. Now, before I start testing, please be careful. I threw in an equals mark here. That means some of these may be included. In other words, you've got to darken them in. And the others may be open for sure. Can anyone tell me first which 2 are definitely open? And I think a student gave me earlier, these. Would that make a 0 denominator? If I replace x by 0 down here, or if I replace x by -2. So I'll quickly say, hold on, Professor, before you start testing, you cannot use this, those 2. Now, if someone tell me why you think I'm allowed to, and I'll go ahead and do it, but I need a reason. Why am I allowed to darken these 2 in, which makes a big difference? 2 are open, 2 are closed. Why am I allowed to close in the last 2? What saves me here? That allows me to darken those last 2 remaining critical numbers, close them in, while over here, I think, we closed something over here also. So what is allowing me to do this on the -1 and the +2? What saves me? You see that equals mark? If that equals mark were missing, everything would be open. The equals picks up those that I would use and not run into a 0 denominator. So guys, if I replace x by -1 down here, you will not get a 0 denominator. It's safe. If you put a 2 in down here, that denominator, you will not end up with a 0. So you're safe. So those 2 can be used. Now, look how much time it took me. Are you guys appreciating this? I should be in chapter 5 by now. We should be in chapter 5 doing trig. Now I'm gonna start testing. Now I'll do it quickly. quickly. I had to show you. You're asking about this. Guys, I'm gonna leave this up to you. We'll just set it up for you. You know the routine. You're supposed to select a number of your choice. And out here, I don't care what number you use, I'm gonna throw in this. I may not finish this one up completely. In between -1 and -2 is awkward. Maybe -1 and 1/2. I can try that and see if that would help. That's all in between. Between -1 and 0, that's awkward. Let's try -1/2. I gotta try something. You could try -3/4, -5/6. Between 0 and 2, well, let's try 1 for that one. And out to the right of 2, I'm gonna try 8. Does everyone agree those numbers do fit those intervals? Test numbers? Now, I looked at the clock here. I'm gonna let you finish this one up. So when you get a chance, finish it up and then shade in, show me which ones work, and then write in interval notation. Okay? We're not gonna do it right now, but you. Okay, are we okay with this one? Okay, so make sure you try, because who knows, you might see something like this on the exam next Wednesday. Okay, all you have to do is just test and see what you want here. And by the way, you're looking for something negative, less than 0. Now, that's it, that's done. That now takes me back to functions, where we should be. Did I start out with functions last time, f of x? I gave you a function and actually find f of this, f of that, so forth and so on. Now, in my 10 minutes before we take a break, I've got that quiz I'm worried about tonight. To do, I do this. Guys, on functions, let me do this right quickly, then we'll take a break here in a few minutes. Part 3, I think it's part 3 coming up. Squeeze it up here. Functions. Notation. F of x. H of t. G of w. Most of us are accustomed to like f of x. Could be written in terms of another variable, t, w. So if I see that notation, that means it is a function. That means, I think I had a student read the definition from the handout last time for a function, and we decide what a function should be. Now, in my few minutes here, please tell me for a little reminder. Let's start out with this. If I gave you a set that looks like this, ordered pairs. Would you classify that, just those ordered pairs, as a function? Would they represent a function? Now, what does one look for to quickly identify? Is this a function or is it not a function? You guys, help me out. Do you think this is a function or not a function? If it's not a function, we'll move on. If it's a function, well, that's for the domain, range, and so forth. Is this one representing a function? -2 is paired up with 4. The definition the student read to me on Monday says -2 have better not be paired up with anything else. Do I have -2 paired up with something else? No. -1 is paired up with 1. Do I have -1 paired up with anything else? No. I'm satisfying the definition. 0's with 0, that's fine. 1's with 1, that's fine. I know what many students were looking at. They said, wait, professor, you've got 2 of these paired up with 1. That's fine. It can still be a function. Then you can list the domain and the range there. Now, if I limited time, if I had turned it around like this, get back into what I want here. those ordered pairs represent a function? No. If I look at the ordered pairs, 4 is paired up with -2. Yeah, I don't have 4 paired up with anything else, that was okay. I've got 1 paired up with a -1. Do I have, later on, 1 paired up with another number, something else? Can't do it, not for a function. This is not a function to work with. Now, I'm gonna close down here. Can anyone tell me, since I've done some graphic with you, can anyone tell me, close down before the break, if I go to a grid, right quickly, and plot those in the black, plot those points, good enough. So I got -2 up 4, -1, 0, 1, let me get ready for it. -1, -2, 0, 1, 2. I'll make a real big sketch, guys. A -2 up 4, let's put it in black. -2 up 4 is up here somewhere. -1 is up 1, let's say up to here. 0 is with 0, it's here. And I reach 1, and 1 is up to 1 here. That's the way they look. Is that true? Now if I should extend, and write more ordered pairs rather than just those 4 that I have up there, please tell me what type of a shape, if connected, is what happened here. If I connect what I have right now, I'll extend it. Am I looking at something, something like that? Is that the graph of a parabola? I didn't plot additional points, but am I getting the shape of a parabola? Now, before we take a break, the other one. I'd like to graph it on the same grid, but I don't know why I have room here. The other one's a little bit different. Over here. Let's see what it looks like. Guys, the first order pair in blue one is out 4, down 2. Let me get ready for it. Out 4, down 2. Okay. That marker works. There we go. I got out 1, down 1. I'll mark 1 here. Get ready for it. 0, 0. Got you. And then I got 1 again. Let's plot these points. -4 down 2. Is it -4? Yes. Okay. -4, +4, -2. I don't have a -4 in there. I think that's wrong here. By the way, guys, if I plot out 4, down 2, I think it was. It's down here. Quick sketch. Out 1, down 1. It's in here. 0, 0. It's here. Out 1, up 1, there you go, my last point. It's up here. Out 4, down 2, out 1, down 1, 0, 0, out 1, up 1. Do I have those represented correctly? Plot the points? Now if I connect these, what's the shape? Does it look something like this? Arrows to show it goes upward. Yep. Is that the shape there? Now please tell me, is that also a parabola? Except it's opening on its side. It's not vertical, like the other one. Now can you tell me about the graphs here, before I leave here? How do I know that this one came out to be a function? Which I think we identified it as a function, the black one. The blue one, I see right there written, is not a function. They want to tell me, just looking at the graphs, suppose the graphs have just been given to you. Just based on the graph. That's all you have, just a graph. Is this the graph of a function? This one is, this one not. What's the difference? Go for it.
Does the diversify the lines that like overlap?
give you a series of graphs on the test next Wednesday. And all you do is tell me, yes, it's a function, Professor. That graph represents a function. No, Professor, it's not a function. What can you easily do if the graph is provided to you? I write graph for you. And I ask you, yes or no. What can you do?
Oh, you could test with a straight vertical line.
They call it a vertical line test. If you pass a vertical line anywhere you wish, I got it on the story in one place here. Anywhere you wish, let's try it here. If you place a vertical line anywhere you wish, how many points of intersection are you having with that graph and your vertical line? 1 point of intersection. If I try the vertical line test over here, how many points of intersection do I have on this graph? 2. So to be a function, you should have only 1 point of intersection. It's called the vertical line test. Okay? Guys, I think, I don't know whether you're enjoying this or not. By the way, I think I'm teaching this class in summer. You might want to join me during summer if you're not enjoying it now. Yeah, if you're not enjoying it now, you may say, oh, Professor, can I come into your summer class? I think Anna's gonna be with me, I think. Mark's gonna be gone. Yeah, I'm enjoying it now, say, Professor, can I get into your summer class? Yeah, come on over. You must do with me again. 6 weeks. You don't wanna do that. Okay, that's, hope you guys take your, 10-minute break. Got just a little bit more to say, and we'll start.